Hello, everybody. Today we want to present to you our findings on the development of epistemological beliefs in the course of mathematical studies. We, that is Benjamin Rott and Anna Schreck from the University of Cologne, have carried out the following study throughout the years 2017 till 2019. At the beginning, we introduced to you the definition of epistemological beliefs that we are referring to in this study. The definition that we are using is of Hofer and Pintridge from 1997, who claim that epistemological beliefs are a person's individual beliefs about the nature of knowledge or the individual beliefs about the nature of knowing. So why is it important to study the development of epistemological beliefs throughout the course of educational processes? So there are several studies that indicate that epistemological beliefs affect actions in learning and teaching situations, but how? Well, the instructor's individual beliefs coin the teaching style, and the teach information is absorbed by the learner, and the image of knowledge that is projected is also absorbed by the learner. So the learner's individual beliefs are indirectly shaped by the teacher's beliefs. So there are two important questions, according to Connolly et al. 2004, when you look at the development of epistemological beliefs. You should firstly ask which traits of epistemological beliefs are actually developing. And the next question you should pose is, what is the nature of epistemological development like? And there is the answer that was given by Hofer and Pintridge in 1997. And they say, if you look at epistemological beliefs, you will find two areas of beliefs. You will find beliefs on the nature of knowledge. So those beliefs answer questions about the certainty of knowledge or about the structure and simplicity of knowledge. And you can also look at the area of beliefs on the nature of knowing. So beliefs on the nature of knowing concern beliefs on the source of knowledge or beliefs on the justification of knowledge. So there are four belief dimensions that actually are the traits of epistemological development. Now we're picking, for example, belief dimension certainty of knowledge, and Hofer and Pintridge distinguish like stages of development. So assumptions that claim knowledge is absolutely certain, stable, and definite are associated to naive beliefs, less developed beliefs, and assumptions that claim knowledge is uncertain, flexible, and temporary are associated with sophisticated beliefs. But there is criticism on this stage-like development. There is claimed that there is a certain flexibility of epistemological beliefs, and that the common use of the epistemological questionnaires that was created by Schomer in 1990 is not useful to the research about epistemological beliefs. Questionnaire of Schomer is a questionnaire of closed items. Stahl, for example, says that this is not valid enough, it's not reliable enough. You also have to consider the context of the belief statements and the belief argumentation. Hofer himself says that you also have to take into consideration the discipline and the domain in which the epistemological belief was expressed. This claim is actually supported by the findings of Rott et al. From 2014 till 2017, who investigated the epistemological beliefs in the domain of mathematics, and they found out that belief positions in mathematics cannot be tied to the justification in such a strong way as it was suggested by Hofer and Pintridge. So they, for example, presented this table and said, okay, you have to distinguish position and level of argumentation. And for the belief dimension certainty of knowledge, you can distinguish between mathematical knowledge is certain and the position mathematical knowledge is uncertain. And then you can distinguish as well between inflexible argumentation and sophisticated argumentation. So, for example, you can also justify the claim mathematical knowledge is certain. How could they find out about the argumentation that was behind those positions? They used questionnaires with open-ended questions, and just to stimulate the argumentation, they presented prompts on certainty and justification of mathematical knowledge. We will see those prompts later. And they also developed a coding manual that distinguished between belief, orientation, or position and the level of argumentation. And there was further research done by Rod and Leuders, not only for the belief, position, justification of knowledge that we have seen. Now we look at the findings concerning the belief dimension, certainty of knowledge. And here again, pre-service teachers were asked, and in 2014, at the first week of the winter term, and the coding manual distinguished between position and justification, and the answers were coded independently by two raters, and Cohen's cover was 0.87. And again, if you look at the table, you see, okay, they can argue for mathematical knowledge is certain and mathematical knowledge is uncertain. They can argue for both positions sophisticatedly as well as inflexibly. The Hofer and Pintridge stage-like development model doesn't apply to the mathematical domain, obviously. But what is interesting for us now are the following questions. Again, is can the students' beliefs can be validly distinguished from the belief position? Are there differences in the beliefs of students of different educational programs? And if there are differences, how are the belief positions and belief justifications distributed? And is there a coherence between the belief dimensions, certainty and justification of mathematical knowledge in the data? So we want to look at those questions in the course of educational process. How could we find out about these questions? Students of different mathematical study programs at the University of Cologne in a longitudinal study. We had 3 rounds of measurement. Here you can see that students were from various study programs. Some were more advanced and some were less advanced. Which instruments did we use to find out about our questions? We used the open-ended questionnaires that already Rod et al. Developed and used in earlier research. And questionnaires had prompts at the beginning, so the quotes from mathematicians about the two positions. For example, mathematical knowledge is certain, mathematical knowledge is uncertain, and those were stimulating the students to answer the following open-ended questions here from A till D, and they had 15-minute time in the lecture to answer those questions. And the same open-ended questionnaire was used for the belief dimension, justification of knowledge. So they didn't only answer questions about their beliefs on the certainty of knowledge. Yeah, and then you see what happened next. The answers were coded according to Rod's coding scheme from 2019 that distinguish also positions and level of argumentations. And actually, 4 level of argumentations were distinguished by Rod and are also distinguished in this study. You don't see a 4th level, the 4th category of coding that was no justification, since it was no answer actually. What were the results of our study? First of all, due to the longitudinal research design, you have different approaches to look at the results. We actually only want to have a total perspective. As you can see here in the picture, there are students that participated in all 3 rounds of measurements, and there are students that only participated in 2 rounds of measurements. So there's an overlap, and it is difficult to compare the results of the years. What could we see if we looked at 2017, 2018, and 2019 results, first we could see a shift in positions. So from uncertain towards certain. If you look at the belief dimension, certainty of knowledge. And you can also take a look at the inductive and deductively justified claims. And you see also a shift, and there's a shift towards deductively justified. And what else can we see? If you look at 2017, and if you relate the position and the level of argumentation and look at both belief dimensions that were questioned, and if you look at the chi-square values and the probability values, you see actually that level of argumentation and position are statistically independent. This also supports again Rod findings that in 2018 there is a surprising shift, and it is a shift if you only look at the data concerning the belief dimension justification of knowledge. You see a shift towards deductively justified. If you look at this, if you look at the value that for deductively justified and sophisticated argumentation, you see that 28 people could argue deductively justified in a sophisticated manner. And this is far more than the expected value in brackets behind. And you see also in 2019 a shift in both belief dimensions. You see that there is dependence and that there is significant dependence. There's a shift throughout the years towards the positions certain and deductively justified, and there's a shift also to argue for those positions in a sophisticated manner. If you look at the different study programs and at the average level of sophistication and argumentation, you see here, if you look at the average values, you see that students from the study program Bachelor of Science Mathematics justify in a much stronger way their positions than the rest of the students from other study programs. What the least post hoc significance test showed was that the Bachelor of Science Mathematics students argue significantly better. And the same goes with the belief dimension justification of mathematical knowledge. Here is an overview of the shift in positions regarding the different study programs. And if you look from 2017 till 2019, you see the shift towards mathematical knowledge is mostly taken by teacher students for upper secondary school and Bachelor of Science people. And here the shift is from inductively justified towards deductively justified is taken by almost all students in 2019, except teacher students for lower secondary school. They are staying with inductively justified. We could also detect the coherence of belief dimensions, and if you look at the data in 2017, 2018, and 2019, you see that there is a significant dependence, and you see that the dependence is with the both positions deductively justified and certain, and inductively justified and uncertain throughout all 3 years. So deductively justified and the position certain are often adopted at the same time. Same goes with the position inductively justified and the position uncertain. They are preferably taken together. Yeah, we now can discuss the reasons for the discovered tendencies in beliefs. So why are people from more demanding study programs adopting preferably the belief positions, and this also in a sophisticated manner, sometimes deductively justified and certain? Maybe you can explain it by the nature of the lecture that they are attending. There's like always definition, theorem, proof. Example, this regimen of the structure is like very present in this. What also has to be discussed is the format of the study and the design of the study, and it is, as you have seen, difficult to evaluate the data and to interpret the data, because the qualitative study can also be a problem. Like, many people don't want to answer, and therefore you have no justification, and you don't know, okay, what is the reason for it? Is it a sign of no reflection on the question, or is it a sign of like no motivation? How representative is the study? We would claim that it is quite representative for German universities, since the University of Cologne, and where the study was conducted, is like diverse university. Consequences for university teaching. Yeah, this is the main question at the end of the study. So what actually do we want to teach? Do we want to reach a certain frequency of position? I think that is not desirable. The thing that we have to work on is that people reflect what they are doing, and that they develop a comprehension of the subject.